the diffusion of solid in gas is dust particles in air. Dust particles are solid and air is a gaseous state. So dust particle in air is an example for solid in gas. Otherwise you can take the examples of tea bags in hot water. In tea bags solid particles are that is diffused in hot water. Okay, that is water vapor. These are the examples for the solid in solid, solid in liquid, solid in gas. Now liquid in solid we have already seen, salt in water, water in salt, liquid in liquid. Liquid in liquid you can take any two liquids like water and acid. It is an example for diffusion of liquid in liquid. Then liquid in gas, very good wonderful example, that is oxygen in water. That is very much essential for the aquatic life. If the diffusion of oxygen in water is not there, then aquatic life is not at all possible. And gas in solid we have already seen, gas in liquid we have seen, gas in gas. The best example is air itself. Air is a mixture of gases. These are the examples for the diffusion of solid, liquid and gases. And now the next one is compressibility. Next one is compressibility. What is compressibility? By applying a force, you are trying to bring the particles closer. This is called as compressibility. And now I told you that solids and liquids you cannot compress. Solids, liquids you cannot compress. And whereas gases can be compressed. Let me show you a simple activity to show that solids and liquids cannot be compressed, whereas gas can be compressed. This activity you can try it at home also. Only thing what you need for this is a syringe. Just don't have the needle of the syringe. You just remove the needle part. You need only this part of the syringe. Now, in this syringe, this part is called as piston. What is this called? Piston. And this one is the nib. I am saying it as a nib. What you have to do is that you have to remove this piston and you cover this opening of the syringe with a tape and fill it with a solid like soil, sand, anything inside it. Even if you cannot go outside, you can fill it with sugar or salt, whatever solid particle, whatever is available at your home. Now, after filling it and closing this nib also, if you try to push this piston down, you won't be able to move this piston down. This clearly shows that solids cannot be compressed. Now remove that solid. Now you fill it with water and try to move the same piston down. You won't be able to do it. This also clearly shows that solids and liquids cannot be compressed. Now you just close this one and try to move this piston. See, though I have closed it, I am trying to move this piston down. This clearly shows that gases can be compressed, whereas solids and liquids cannot be compressed. During compression, what is actually going on is this. For example, this is piston, and this compressibility can be done in two ways. One is you have to apply pressure. How you are applying the pressure? Pressure is force by area. Force acting on an area is called as pressure. You have already studied in 7th. What is pressure? Force acting on an area. I am applying pressure in this syringe. By applying how? In two ways I can create a pressure here. This is a piston and this one is a cylindrical jar and this is a piston. Okay. I can apply the things in two ways. One is that I can move the piston down. When I bring the piston from there to here, what I have done, I have decreased the area of the glass jar. The area initially it was this much area it is having. Now I have decreased this area only to this much. So by decreasing the area, if the area decreases, the pressure increases. Right? Now, another way is that, for example, 5 Newton force I am applying here. Initially, I am applying 5 Newton force on the piston. Newton is the unit in which force is measured. Now, I can increase the force acting on the piston. I can make it as now 100 Newton. In this case also, what happens, force, by applying force also I can increase the pressure. Two ways I can increase the pressure. One is that by increasing the force I can increase the pressure. Another way is that by decreasing the area I can increase the pressure. So pressure is directly proportional to force and indirectly proportional to area. This is all about compressibility. Next one is density. What is density? Mass by volume is called as density. Density is equal to mass per unit volume is called as density. Now, let us take the examples of solids, liquid and gas. Iron is having highest density. When you melt the iron, it goes into its molten state. Then molten iron is having less density than the solid iron. If it is possible, if you heat that molten iron, if it changes to gaseous state, then gaseous form of iron will have the still lesser density than the liquid iron. So solids have the highest density, liquids have less density than solids but more density than liquids, whereas gases have the least density. But there is an exceptional here. God, as I told you, God is a wonderful creator. Can you give an example where the density of the solid is less than its density in the liquid state? Think about it. Okay, if it is in a class, I would have given you more time for thinking about this process. You would have seen this in your day-to-day life. Nowadays, you would be doing this process. Next time, if you fill the ice tray at your home, just think this process. When you are filling the water in the ice tray, you fill only a little lesser than its rim. Up to that only you will fill. And now, if you are filling ice tray at your home, helping your mother, next time if you do this, take care of this thing what I am explaining you now. You fill a little less water in the ice tray when you are before keeping it in the refrigerator. Once if you keep it in the refrigerator, then when ice is made, when you take out the ice tray and see, the ice comes up to the brim. Sometimes it overflow also. That means the mass of ice and water. You can see when you put ice, just wait. When you put ice in water, it floats. That means the density of ice is less than that of water. That is why it is floating. Reason for this is ice occupies more volume than water. For a given mass of ice and water, for example, you are taking a water bottle and you fill the water bottle, 1 liter water bottle you have taken, and half liter up to that you fill that water. half kg of water you fill in the 1 liter of water bottle. Now you keep it in the freezer, and after some time when you take it out, the mass remains the same. That is, mass of water and the mass of ice remains the same. That is half kg only, ice as well as water. But when you see the volume of ice, it has come up to the brim of the bottle. This clearly shows that ice occupies more volume. That is why the density of ice, that is mass, remains the same in case of ice as well as water, but the density, that is volume, increases in the case of ice. For example, let us take the mass of density of water. Let us see. Density of water is half kg you have taken. It's 0.5 kg, and volume, for example, let us take 100 meter cube. Now in the second case, if it is in ice, 0.5 kg remains the same, but the volume increases, it becomes 1000 meter cube. So this is liquid and this is gas, solid. So in the case of ice, the density is becoming less because of it occupies more space. Ice occupies more space, that is why the density of ice is less than that of water. This one is a boon for aquatic life. That is, if the density of the ice is more than water, suppose let us consider, then what would happen in the aquatic region or aquatic life in cold countries? Once if the top layer of water changes into ice as the temperature goes down in winters, then that ice density, suppose if it is more, then it will sink in water. Then the next top layer converts into ice, sinks in water. In this way, the whole river or sea get frozen. So aquatic life would not be possible. Instead of that, God has created this, ice density is less. So when the top layer of water changes into ice, it floats on the water and even it forms a layer of ice, and below this layer of ice there is water where aquatic life is possible. So God has created everything with a reason. That reason we have to find it out, why the density of ice. Because of that only aquatic life is possible. That's all from me for today. You can go through the question and answers that is given after this topic. Even blue questions you can say. Second blue questions you have to go through it. In the next class, I will be sending you the blue questions with answers. Children, whenever I am sending the blue questions with answers, you go through the answers. For your understanding only I am explaining. You can write the answers in your own words also. Okay, till then, take care, keep reading, keep helping your parents. Bye, see you.